As a part of SciStarter, every year we go through our largest efforts in April. April is called Citizen Science Month, and this year we have a particular goal of 1 million acts of science. We want to get 1 million acts, 1 million data points, 1 million contributions to projects, action contributions, and just activity around citizen science. And so in order to do that, we need your help, and we really think it's a great project idea for a classroom because it engages your students in things that they would never have thought possible necessarily. They probably don't know that they can contribute science directly to NASA scientists that will use it to understand more about our planet and the planets around us. So as a part of Citizen Science Month, we are inviting teachers to join us in a bigger program. But to back things up, just in case you're curious about what Citizen Science Month has come from, it used to be Citizen Science Day, and it's evolved considerably. It's now a coordination of efforts for the entire month. And we work with many partners, and everyone can be involved anywhere, everyone to participate in projects, and they don't need to have any experience. So if you're worried about your kindergartners, that's fair. Kindergartners especially probably won't be able to submit their own data, but there are ways that they can still be involved and take part in the science before the more before age appropriateness runs out and you'd need to submit data via an adult. So we'll talk about those things too. So speaking of what that 1 million acts of science collective means is it's a couple things. It's a many things. If you're thinking what is an act of science, I have a bunch of examples here for you. So if you attend an online or in-person CitSci event, CitSci is short for Citizen Science, that's an example of an act of science. For example, you being here, if it was April, this would be an act of science. You would be able to say, I contributed one time, I was at an event, and you'd be able to mark that in a self-reporting form at the end of the month. You can also join a project to play games that accelerate medical research. You can join a project to play games to help with other types of research as well. There's not just medical research. You can analyze online images to help make discoveries. That's like conservation oriented. That's brown dwarfs in our interstellar surroundings. That's a lot of NASA projects in particular. You can share pictures of nature to help scientists spot biodiversity trends. If you have ever heard of iNaturalist, that's our prime example there. You can use your smartphone to monitor your environment and so much more. There's a lot of examples we have, which is why we are a database of projects. You can find all kinds of things. And that said, we're going to focus it in towards what that means for you as teachers. So if this already seems interesting to you, you are more than welcome and very much invited to join us in this actual campaign. The link just dropped into the chat is a bit.ly link for signing up as a class. So if you represent a classroom, you can actually just go in there and add in your details. I have this link later if you want to wait until you've heard more, but just so you're aware of what's available to you now, that'll be at the end of there too. And what that means is if you sign up, you'll be attending a 30-minute monthly, or it's monthly, but you only have to attend one, a virtual meetup just to do a support call to see like, what are you doing in the classroom? What would you like to do? How can we help you? It's essentially just like a temperature check for us to figure out what you need. So it's meant to be for you, not to make it difficult. You could be in there for 3 minutes to just ask one question, and that's all you'd need. You are also going to be promoting 1 million acts of science in your classroom just by default, so that's not really much of a lift. And if any of your parents are engaged in your classroom, any materials that go to them about 1 million acts of science and doing citizen science in the classroom should mention 1 million acts and go to the SciStarter page for Citizen Science Month to just kind of orient them in knowing what this is and give you a little bit more of credibility in the topic. And then at the end of the time, the big thing is because it's not just a science project, it leads up to us actually contributing to projects and making the research better. That last part is the most critical, is by May 15th, we're reporting all those estimated number of people and estimated number of acts you do in your classroom or within a community. So for example, if you do an activity in your classroom, you count up how many people were there that day. And that either you would write in the attendance for that and how many data points were submitted into the research. So maybe that's one submission point because it was the whole class working on one thing because they're kindergartners or in the lower elementary school grades. And so you're just trying to do one thing all together, but they're all participating and learning about it. That's one contribution, but that's like 30 kids. And so that's important too. That could also mean a bunch of teenagers going on to stall catchers playing the medical research video game and getting a ton of contributions in there because every time you help that game, which is every point you earn essentially, or every every video you watch, if you're familiar with stall catchers, would be a data point. So lots of ways to get engaged, various ways in which to count your acts and participation. So, and then I will come back to this too. I think it might be useful to return to this later instead of showing you now. But SciStarter has specific tools that are geared towards helping educators, some of which were built for educators and some are just oh wait, this is excellent for a teacher. And so I'm adding them in here. And they'll be dropped in the chat. Thank you, Roland, for doing that, where we have an education-specific page. This one allows you to look at it by grade level. That actually, I changed my mind already. Let's look at that one at least, where they're all based on grade level. So we have an introduction to what it is, pre-K and through 2 and pre-K 2 and up, 3 through 5, 6 through 8, all of these amazing projects. We actually have an event about Monkey Health Explorer coming up soon. I'll tell you about it later. And so lots of different ways to get engaged there. Oops. Back to that. There's also an affiliates page, which is specific projects that are tracked contribution-wise, so we can tell how many contributions it gets over time, which is helpful for us in terms of the 1 million acts. But you can also use it as like a competition where kids, the students can actually track how many contributions they're doing throughout the month. And that would set you up really well for like a competition, for example. So the Finder is just the database. So if you're looking for specific projects or topics, that's where you would go. There is also a blog from SciStarter that has a multitude of education-focused blogs. We're on YouTube with a ton of instructional videos and videos just like this, where we talk about a specific topic for the webinar. We have training, which I'll actually talk about again in a bit, because it is incredibly useful in terms of just having an activity for your class. So in that case, it would be something like the foundations of citizen science. Your entire class learns and they actually earn a badge that's specific to the skills that they learned. This is something that could end up on your LinkedIn profile, for example. So for especially the older grades who are looking for like professional development or certifiable like skills that they've earned, it's a really excellent way to show that off. And then citizensciencemonth.org has a million resources for you just as a teacher and also as anyone interested in Citizen Science Month. You can look into it for upcoming events. You can look at the event support materials that I'll actually mention later on as well, and a multitude of other things. So I've heard my voice enough. I would like to hear from you all. If you are on Zoom with us, we would like to know, what grades do you teach? Why are you here? Like, what kind of education are we talking about? I'll ask about topics and subjects next. But if you are a teacher or you work with the youth in any way, what kind of work do you do with youth? Are you a high school teacher? We have one high school teacher with us, Jody, already. And then we have elementary, because 5th grade is still elementary. Sometimes I think it's middle school, but it's not. I don't think so. Okay. While you're thinking about your answers, that second question I already kind of said, so I'll show you what that is. And you can add your answers in the chat as well. Unless the chat is, no, you should be able to. Okay. Oh, awesome. Thanks, Roberta. Girl Scouts. Yeah. K-12 program manager. So you've got all kinds of groups. And I see someone has raised their hand. Can you write your answer in the chat? We can let you speak at the very end too if you have questions. But if you have ideas, put them in the chat for now and I'll come back to you. Preschool, elementary, and some middle school, also a big range. Yeah. That's the great thing about citizen science too, is you can really find the range of projects too that'll interest them across the board. All right, I will keep moving. So because you're tired of hearing my voice already, I'm going to shift gears over to some of our guests here today. They are both joining us. Richard and Jody are both joining us from Broward County in Florida, from their school district out there. And we have a special relationship with them at SciStarter. So SciStarter and Broward teamed up years ago to create a program that makes it really possible for students to get engaged in citizen science in a way that's integrated into their school experience. So we actually have a partnership where we have a tool installed in their Canvas site. And so all the students who use Canvas can go in and actually do a project as assigned directly. So that's not exactly a resource for everyone, but it did allow them the unique insight to actually talk through what citizen science might look like in the classroom. They have a lot of experience of maneuvering it to see how it fits well into their classroom. And so I brought two of them here who are actually certified citizen science coaches for Broward, who are the go-to people to talk to if you need assistance within within the school district. They're the people that you can reach out to, that the other teachers can reach out to, and they train their schools and their teachers to do this process. So they've had a lot of experience. I'm going to go ahead and drop my screen share for a moment, and double check if Richard, if we can hear you, just to, yeah? Yes, we can. Great. Oh, thank goodness. Yeah. Amazing. All right, I'm going to hand it off to you then, Richard, first to tell us something about your classroom and what you've done with citizen science.
Okay, so first of all, I teach at a 4th and 5th grade gifted high achieving classroom. So I use this throughout the whole year in my class, but specifically I create like independent research projects. So I kind of make it like I gear it towards whatever standards that I'm working on or in the classroom, and then I create these projects that are kind of, they're focused on those standards. So for example, one of the ones the students are doing is the sunflower project, which is amazing because we're researching about pollinators. So ideally, all they really have to do is go outside, and if they see a bee near a flower, then they record it. If they don't see the bee on the flower, they still record it because it is science. And then what they'll do is they'll bring the kind of flower in, and then we'll like research to see what type of flower it is, and they have to fill out the information. But that's really just a project part of Science Starter. Really what they've been doing up until that point in time is, they've been creating a PowerPoint presentation that, like I said, it's specific towards the standards they're working on. So like anything with animals has to do with adaptations or animal classifications. So they're itemizing all those specific things on their PowerPoint, and then kind of the culminating activity or thing that brings it all together is the Science Starter. And I try to gear towards specific standards we're working. Like you just mentioned a minute ago was the stall catchers. Well, that one we worked, the nervous system and, the circulatory system. So then they would have to create a PowerPoint that, itemizes those specific standards, and then the culminating activity would be them, doing the Science Starter through the activity through Science Starter. So that's pretty much what I do in my classroom. And I think like when I first learned about it through Broward County had a class, a class for that, and I was looking for project-based learning, and I found something really even new and cooler than that with Science Starter. And like as I do the lessons, now it's more part of my classroom than it is just a project. Because if the student is done with doing something, or like, okay, go outside and do your Science Starter, look at the clouds, because they can do a Science Starter of what the clouds were that day. So it's kind of geared towards it's part of the classroom now rather than just a project that they've done. And it's like the kids will be walking outside, look, there's a squirrel. Okay, awesome. You can record that in on the squirrel project that's on Science Starter. So that's what I do in my classroom. So that's what I have. Okay.
That's an excellent examples. Thank you for also describing the fact that you connect it to your standards, because I think that's something that people are weary of when they're like lesson planning. I know even in our group of Broward County schools and talking with coaches, it's been an area that really helps to be able to see it in comparison with standards. So if you're able to look at your standards and then compare it to projects that you find on SciStarter, or vice versa, look at your standards and make some guesses on topics you can look for, that'll really help you kind of align with exactly what you want to do. You mentioned something super awesome, and I wanted to bring it back. You mentioned if they don't see something, they don't see a bee on the flower, they don't see the pollinator, that's okay too. If any of you are worried about like, what if it doesn't work? Like what if you get 0 of something? We all know that 0 is still a number. It's a data point that's really important. And so even if something kind of doesn't work out, it's a good teaching opportunity to talk through what the 0 data point really means, especially for something like pollinators. If you don't see any pollinators one day in this area of your garden, maybe that's a different question of what's going on in the area? Why don't I see pollinators? Are there other factors? And you can kind of build an even bigger conversation. So yeah, I appreciate you adding that in. Awesome. I may have more questions for you, but I'm going to let Jody take over so I can ask you both the same questions too.
So I teach high school science. I've used SciStarter in a variety of classes. In my AP class, I did stall catchers and a few other high-level science stuff when we were on that topic. In the curriculum, it was a way to get them engaged and see how what they were learning about in theory connected to the real world. And some of them for SciStarter got so addicted that they continued doing it after the assignment was done, which I thought was pretty cool. but mostly I've used it in my research classes. I teach at a environmental magnet, and so we have research classes each year. And so with the freshmen, I just did one where we did a combination where they worked in pairs, and one of them used Seek to identify a flowering plant, and then together they did the Great Sunflower Project to see who was visiting that plant. And ironically, the day that we were out there, there were no pollinators out there. And so there was a lot of conversation about why and were they doing something wrong and what did that mean? And so for the connection to the curriculum, for me in that class, it's mostly just been about the scientific method, about making observations, about thinking about data collections, thinking about being careful observers, not as much tied to the curriculum standards other than the nature of science and the practice of science. And so because of that, we've done a whole variety depending on who was in the class and what their interests were. So I've done a few that work that are kind of my go-to, but then depending on who I had in my class and what their interests were, we did the clouds one year. We did ant picnic one year. And so I have them, because they're older, look at the SciStarter website and pick out ones that might be interesting to them. And we've just sort of let them choose. And so it gives them ownership of their learning. It gets them a little bit excited. Again, it reinforces that idea of science and the many ways that everybody can be part of collecting important data.
Speaking, but I'm still muted. Sorry about that. Thank you for that example. I love that. I'm excited that you have them explore on their own too, to see like what topics, because it really does, if you're working with older students, especially being able to give them the ownership, I think would mean a lot, which makes me also think, what do you think the reactions are with your students with citizen science versus like your I struggle to think of words other than like your average science project. Like, do you see a difference, or how do you view that, I guess?
I think for them, they find it really hard to imagine that they could collect data that would actually be useful. And so in some ways it makes them feel empowered. And then when they see how relatively straightforward some of the data seems to be, in terms of like the data sheets and what they're collecting, it makes them realize that they can likely do science, which again is an important thing. Obviously, science is more than collecting the data. I know there's all the data analysis and statistics, but at least it gives them that inkling that, oh, maybe I could do this.
Yeah, that's a good point too, because even if they are thinking, or if they're thinking through the idea of like, oh, I can do this, even if they turn out to not want to be scientists in the future, that's kind of the point of citizen science too. It's the idea that we want the perspectives that are not the scientists all the time. So with students, you're giving them the option of thinking through, here's what real science looks like. Maybe it's not the deep stats and like chemical stuff, for lack of understanding of what it might be. But they don't have to necessarily do that all the time. Maybe they fall in love with all of it and they become scientists, or maybe they just realize as adults, they can always come back and actually impact science if they just love science. Like I'm not a science professional by any means. I'm a science communicator. So I guess that is like a half mark. I communicate it, but I know that I'm not a scientist, but I still love it and want to be engaged with it. And so it gives you that option of, you don't have to be a scientist to do everything. You can be involved in all times of your life, right? If you have the time and the motivation, it's there. Yeah.
Especially if you have an interest or a passion, there's probably a scientist out there who wants your data. And so it becomes a win-win.
Totally. You would not believe the amount of, a lot of NASA citizen science projects too, do a lot of work with, they have like really awesome groups of volunteers, right, who love their projects, and they actually do meet and greets with their project scientists to keep them engaged and let them ask questions. So they might not be scientists, but they can still, or maybe they're scientists in a different area of expertise and they just want to know more about what this research is about. Richard, I wanted to give you a chance. Do you want to know anything on the topic of how your students relate to citizen science versus doing a regular science project that does not contribute to real research?
Well, that's part of it for them, is that it's not just, you know, making the volcano erupt when they are taking part in something, and just like Jody had said, they take ownership of it, right? They're doing something for something. They're taking part. They are scientists, you know. It's
Yeah.
pretty cool. Well, I'm like, it's the elementary school kid there. That's what science, like you're talking about, that's what science should be about. It's about, you know, being part of something that's, you know, bigger than yourself. So I think that that's a huge element of what Science Starter is. So.
And what science means to people. Do you have any advice for teachers who are super new to this? Like, what would you advise these teachers to do if they're like first moving in? Maybe it's a project idea, like, oh, this is a good one to start with, or just a way in which to infuse it with or embed it in their lesson planning.
I would take maybe one or two ones that are just and do them themselves, first of all, but then, you know, choose that one and then build upon it. So for me, the Great Sunflower Project was a great one to start with. The marine debris one was a great one to start with. So the ant picnic was one that was really good. So I think if you were to choose one or two that were, you know, you did yourself, I think after you did them on your own a couple of times, you would feel comfortable enough to, you know, release it to your kids for sure.
Right.
Yeah, and I would say that if you're worried about curriculum and standards and all of that, this is a good activity to use on those days. Like if the kids have been testing all morning, something to do fun but still academic during the rest of the day, or a day when the schedule has just gone haywire for whatever reason. It can be a fun and engaging thing to do, and a day when you might not really be meeting all your standards or have the kids have their minds completely open to learning traditional new information. So sometimes this is a fun thing to drop in. And I would say anything you're interested in or you know something about, if you search SciStarter, you can probably find a project, and then, you know, find one that you like, try it yourself, and you'll know really quick if it's going to work with your kids or not.
Definitely. Great advice. In fact, you mentioned the dropping into lesson plans where there might be areas for extra things. If any of you do brain breaks related things, or something that's like let's just remove ourselves, or maybe even like I don't know, a lunchtime or break time where there are some students who just want to stay and talk to you. I had a lot of students like that back in the day in 5th grade. So if that ever happens to you, I wish I'd known. I could just bring up an Instant Wild project from on SciStarter and go to Instant Wild and basically just make them identify what animals they see in a picture, and like camera traps. So it's not something that has to take a million hours. It can be like a 5-minute, you do one observation and that's it. It could be very, very limited, right? So I appreciate the various ways that you can get involved that you two have both described. We will move on to a different topic. Any last words or words of wisdom from our two teachers? Okay. All right.
Go SciStarter. That's what I'll say.
Yay! I will take that out of this video and just make it one of our ads, if that's okay. Awesome. Excellent. Okay. Jill, I'm gonna push it on to you, so I will share my screen again, unless you wanted to. Are you okay with that?
Yep, sounds perfect for the slides. Awesome. Yeah, thank you so much. And wow, great stuff all around. Cannot wait for April. But yeah, citizen science, it's such a great way to turn our students' curiosity about the natural world into impact, into real world impact. And talking about higher ed and all the ages, all the grades, it works well with all ages of learners. It truly is that science that we can do together. And so I'll share some connections related to citizen science and college learners. And the projects can be part of a lab activity, like a science lab, a community project, service learning, undergraduate research, and much more. And it really does work for non-science majors, science majors like environmental science, future teachers, everybody. And so I like to share with students with citizen science, literally the world is your lab, the world is your classroom. And we love turning that curiosity about the natural world into that real world impact. So we can go to the next slide. Yeah, and there's so many projects for the planet. I love the SciStarter project finder. You can find a project for everyone, every student. And this is really great. I kind of focus, I noticed a little bit on projects for the planet because April is Global Citizen Science Month, but it's also Earth Month. And so projects for the planet can be another theme for your 1 million acts of science and doing things for our planet in April. You can go to the next slide. Yeah, and this is another thing that I love. There's projects for online or outdoors, literally everything from A to Z, astronomy to zoology, everything in between. And the SciStarter Project Finder can help you find it. In fact, we were talking about one earlier that works really well right now indoors, and it's sourdough science. And Emma did some great videos on that project. So that's a great winter one or any time in the year. And you just need your kitchen and some just the sourdough ingredients and you're good to go. Really, really fun one for a lab. And next slide, I can give you some examples of some online projects. So this was, of course, you can see a zebra. This was from a camera trap image. I think it was from Snapshot Serengeti, which was a really popular project. There's so many. The Zooniverse has a lot of these. Instant Wild, like was mentioned earlier, CamTrack projects from all over the world. These can be done online. You just need, computer and internet access. Some fun ones with students lately. Oh my goodness, beavers from space. You're studying wetland ecosystems and beaver dams from satellite images. The woodpecker cavity cam, iguanas from above, and a lot more. There's so many, and you're right. Like during break, students love doing this. And next slide. Yeah, the little froggy. So another connection too with 1 million acts of science and Citizen Science Month that we love for our college, like environmental biology labs and classes, is Frog Watch. So Frog Watch is really fun. You do outdoor surveys. You're outside in the field collecting real world data. I've never met a person that doesn't like Frog Watch, and it connects to because April is Frog Month. So that's a fun one. They celebrate amphibians in the spring if you're in the northern hemisphere like we are. And then the next slide, yeah, from the beach to the backyard, there are so many projects. I know some of the colleges on the ocean and the beach, they'll do a lot of the really cool ocean projects. Like the Great Egg Case Hunt is really fun. You're not hunting anything, but you're doing a beach survey of egg cases of sharks and rays, and that could be any age. But that's a great one. So with a lot of college campuses who are lucky to be, beachside, they'll do a lot of beach ones, and if the beach is your backyard, you have that as well. But whether you're in the city, in the suburban area, mountains, forest, prairie, wetlands, at the beach, there's a project that can fit in the curriculum. So we'll go to the next slide. Yeah, so talking about the backyard or the schoolyard or your campus, iNaturalist is a great project for college students, and they have Seek, as was mentioned before, for the younger learners. So I wanted to talk and highlight iNaturalist a little bit because it's a great project where you're getting to survey biodiversity that's around you, like plants and animals, and upload that data. And it actually uploads into the GBIF, the Global Biodiversity Information Facility, but it's a database, GBIF. So students know they are contributing to real world science. And, as we know, scientists only have 2 eyes each, but with all of our students participating in this in the field and making biodiversity observations, it helps the data. It gives a more accurate snapshot to Earth's biodiversity at a moment, place, and time. So yeah, I would encourage this project during April. Would be great, really any time of the year, for college learners or high school learners. It's just a great, there's so many things they can do. Like we've had some students do, they'll make like a field guide. So they'll collect data and then make a field guide for that area. Lots of projects they can do with this one. And Yeah, so you could, for example, during April, 1 million acts of science, like each observation's a data point and an observation. You could BioBlitz your campus, your schoolyard, and if you're lucky, I mean, I know some districts and colleges, universities will have a field site. So you could potentially also BioBlitz the field station or outdoor learning center and classroom area. And actually, that's a fun project in and of itself when students can do like a BioBlitz in their yard or a local park, do it at school, maybe do it at a really natural site, just any of those work where you can compare what you find at different locations. And that leads to new questions about what habitat is needed to bring in this critter and things like that. So next slide. Yeah, so in a nutshell, that project is turning a picture, which we know students love to take those, into data. With college students, we don't have too many restrictions. Most of them have their mobile device, so they can do that. I know in some school districts, some of the websites get blocked. And so sometimes they'll take pictures with like classroom iPads if it's a younger learner on the campus. And then the teacher, the educator, helps kind of pull that data in, maybe through his or her account to post the data. So just lots of options with this one. Next slide. Yeah, so this also helps in a snapshot that it is literally an observation at a place and time. So it turns your photos into data. So that's really exciting. So you'll just set up an account, or the professor, instructor, teacher could set up an account to feed those images through. You'll say what you saw, where you saw it, when you saw it, evidence of what you saw. And I have to tell you, the college learners today are so into technology. I was doing a BioBlitz pre-pandemic 2019, had a classroom of students out on the school campus doing a little BioBlitz. They were, I think the snapping turtle was the favorite observation that day, which is pretty cool. But they were so interested in the technology behind that iNaturalist platform, iNaturalist.org, and the app, because if you're struggling with what you saw, you can use the app to kind of read the pixels, the technology, the AI. It can help read the pixels behind the picture and suggest an ID. And it's surprisingly accurate and very helpful. So I've noticed over the last couple of years, they're very interested in that, the technology behind it as well, which is amazing. Next slide. And then this is key too, to inspire everybody today, that this global database, this global project that's making such a difference in the world and invites all of us to be a part of, it began in 2008 as a student project. So even, as you're working with students, whatever grade, learner, subject, really encourage them, if they're given choice in a project, find something they love and that connects with them. Who knows what'll come of it? So I love that this amazing platform that's changing the world began as a student project as well. I think that's so cool. Next slide. Yeah, and I thought I would connect the group with, if you're interested in using this, the iNaturalist, iNaturalist.org, or the app, because you can upload data either way, photos and information. This times out perfectly, I thought, with 1 million acts of science, Global Citizen Science Month, where we're focused on engaging in science. And it also, April 26th through 29th is the Global City Nature Challenge. So this can be a great one, because I think the observations from this global event should hit, I think, probably over 100 or over 1 million this year. So what a great partner with 1 million acts of science to engage in this project, get lots of observations, have fun in the field, making observations. So yeah, this'll be towards the end of the month for some locally engaged, globally connected science. Super excited about this. And also too, if you do have students who can't get outside, literally everyone can participate in this. We've had some students, we're always about accessibility and meeting the student where they are and their needs. So if you have students who cannot get out into the field, wow, they can contribute in a big way because you kind of the goal is you want to get each of the observations research grade. And so what you have to do for that, say I make an observation and then Roland and Emma are like, yes, that is a monarch butterfly. Yes, that is a monarch butterfly. So if the three of us agree, that is a research grade observation. So your students, your learners who maybe for whatever reason, can't be out in the field making observations, or if they're just interested in helping, they can actually help confirm observations, and they're participating in that science, making that observation a research grade observation, which is the first time that happens, they're very excited about that. So that's exciting. But yeah, I invite you to join this because again, it's a perfect connection to 1 million acts of science and Global Citizen Science Month and Earth Month, celebrating Earth's biodiversity as well. Next slide. Oh yeah, now we have I'll turn it over to Emma. We got some fun stuff coming up.
A quiz question for you all if you were paying attention. I just wanted to mention too, City Nature Challenge. I love City Nature Challenge. I'm really excited to participate in it this year. I help run the Phoenix metro area City Nature Challenge. So I will definitely be training people on how to do the observer role and also the identifier role. IDers is what we refer to them as. And so it really helps, especially since City Nature Challenge is specific to locations. And so if you just have a location in mind that you're like, oh, I love this city or this location, they're participating, but my area isn't, you can still help. You can still help them do well. And you can go online and help them identify. Because when you're in the moment trying to be the best in the challenge, you're taking all these pictures, you end up not being able to identify down to the species. And so it helps to be able to have people on there ready to, okay, I think this is a deer or whatever it might be, right? Snapping turtle, which I have never seen a snapping turtle. So I'm going to look them up. I knew they existed though. So in case you all were paying attention and would like to have a teacherly method of quizzing your students about what's going on with citizen science, I'm curious what your answer would be in terms of this question. What counts A, B, C, or D as public participation in citizen science or in scientific research? So public citizen science has a bunch of names. So if you prefer to call it something else, there are a couple different ones. My favorite is public participation in scientific research. If you do switch, there's other ones too. So A is take a photo and upload to iNaturalist. B, identify mosquito habitats, log data on Globe Observer. C, plant a pollinator garden to increase pollinator activity. And D, test your local tap water and report findings to crowd the tap. Does anybody have an idea as to which ones count as public participation? All right, so we got someone saying all of the above. Any other thoughts? There's more than one of you on here. If any of the panelists want to give their answer too, you're welcome to. It's a keep note of public participation in scientific research specifically. Do we all agree with all the above? Oh. Or y'all are too scared, just like those students who are unprepared for the question. Ooh, Jody, not sure about C. Okay, I'm gonna look at C. Plant a pollinator garden to increase pollinator activity. Okay. Anybody else? I'll give you like 10 seconds. Anybody else dance around their classroom during countdowns? I used to do that, just in case that's a thought. Always entertain them. Okay, so Jody, you have a great thinking process because C is a little off for some reason. So note that in all of these, it involves taking a photo or doing something, identifying, observing, whatever, but reporting the findings, logging the data, upload to iNaturalist. This one is increasing pollinator activity, but does anyone get to know about the pollinator activity? Not necessarily. We didn't mention any of it. So if you're not closing the loop there and actually submitting the data to the scientific research, it does not count as citizen science. So be aware of that because that will help you when it comes to determining if it is within the 1 million acts of science or if it needs to not be mentioned as an act of science, right? So in order to help you understand how to actually embed all these things into your classroom, I came up with a list of tips and resources to assist. So this will be helpful, hopefully. And if any of my guests want to mention anything that relates to these that they want to add to the list, feel free to speak out as I'm going through them. And then we will close out with the meeting. So thank you all for joining us for this long. We have make a class challenge. So if any of you are in a classroom that is particularly competitive, you are super enthusiastic about challenges potentially, and I think it would be amazing. So if you create a challenge or some kind of competition within the classroom, either in teams or in individual competitions, they can be very, very motivating. You also have something called SciStar's event recipe cards. So I didn't show you the Citizen Science citizensciencemonth.org website, but I'll go ahead and actually hit this button for us so you can see what I'm talking about. So on citizensciencemonth.org, which sends you to SciStarter, okay, once you do that, we have all these lovely tabs, and my favorite is event support because it has all these different resources for you. I'm going to bring your attention specifically to event resources or event recipe cards. So if you liked the idea of City Nature Challenge, for example, this is City Nature Challenge built into a program. Now, generally they're spoken with the context of possibly being done at libraries, but with all ages. And so looking at these would be very helpful for planning out how it might look in the classroom and how you might add on to it later. So it's just the general basics that you can add on to. Stall catchers is the Alzheimer's research one we discussed a couple times today. We have one for that. Globe at night, if you want your kids to do some astronomy related stuff, they have to go outside and look at the stars and identify one of the constellations and just see if light pollution exists. So they get to monitor how many stars they see so they can determine if light pollution is really heavy in the area or light in the area, whatever that might be. Great Sunflower Project was mentioned a bunch. We have a recipe card for it, so you don't have to worry about that at all. We've already got it down for you. And then Eclipse Soundscapes, if any of you are in the Eclipse path, that's our recommendation for doing any Eclipse programming with students. It's definitely the easiest to do, I think, because there's one with, it's experiencing the Eclipse in a multi-sensory fashion. So you're not just looking at it. So if you are looking to have your students enjoy the eclipse in terms of what am I hearing? Are there crickets? What are the animals doing? What is the feeling like in the air? Is the temperature decreasing? Those kinds of things are mentioned in the Eclipse Soundscapes Observer. So good to be a part of that one if you're interested in giving them a multi-sensory experience. Also incredibly accessible to anyone who is unable to experience through sight as well. There is a connection to our partner, but in a classroom, this one is more relevant to the parents, so I'll skip on that one. Awesome. So we have a bunch of those available to you. We'll be making more as they become possible. Different projects even make their own, so hopefully we'll add some more from them as well. So that's those things, and then I'll return to this. So, and I saw a couple of things in the chat. Okay. Oh, excellent. Thank you, Melissa. I'm glad you think so. Another piece of advice, scaffold and spread out the project activities. For my teachers online with us, I had a conversation with one of your other coaches that was about having multiple days to do one project, to do different parts of it and add on those pieces that you want to add on as a part of your standards or curriculum, however you want to do it. Richard mentioned an entire project that was done by a student where the cap of the project is actually doing the project, doing the citizen science project. So your presentation, your bigger project is done with a whole lot of curriculum involved, but that capstone of the project is the citizen science project. And that might help you determine like how to actually let the flow happen. Assigning the foundations and data literacy trainings is actually a really great way to do it kind of hands-off if any of you want them to learn about citizen science, but you don't necessarily need them to do it in the classroom, or you're running out of time, or whatever it might be. You want them to have some professional development skills too. Those two trainings are fully online. They can just do them in their own time using their accounts on SciStarter if they're 13 and up or whatever your rules might be. And there, in particular, Foundations is great just to understand the general ideas behind citizen science and get some experience. Data literacy is one that I really love just because it really teaches you the meaning of the data within citizen science. And it's really useful for, I wish I had known about it when I was a 5th grade teacher, because if you're teaching data, it gives you a lot of opportunity to look at it in a real scenario. So it should be helpful. We mentioned this already. Jill mentioned the accounts that you can have as a teacher or a class. Having these for younger students is really useful. So if you have a class set of something that you can log on through one email or log into an account through one email to be the place where students record their data, that can be incredibly useful. I don't want anyone to feel like they can't participate and close the loop on the citizen science and make sure the data is submitted just because the students can't have accounts. That should not be a stopper. That's something that we're very aware of, and we want you to know what the other options are. So if you're interested in learning more about like other ways, or you're kind of stumped on any of these things, feel free to reach out, and we'll give our the email at the end of this call too. And these all related to closing the citizen science loop. So just make sure that you're submitting the data at the end. Again, if you need help with any of those things or trying to figure out how to fit it in, I'm happy to help. So any other thoughts come to mind, go ahead and interrupt me, any of my guests, if something came up that you wanted mentioned, but I will move on to our questions as well. So
And Emma, you reminded me of something too, like thinking about workarounds, because you brought up such a great point. Like if you have to adapt or something, you can always make it work. And even we had a fun one where we pulled historical, like it was a ton of data, historical citizen science data from a project, and then turned college students loose on it. And then we were like, what themes can you tease out? What are you seeing between like, you know, weather trends and the date the first bird migrates back to your area, or weather trends and the first over years and hundreds of thousands of data points from people across the world. And then what's the first bud date in some plants, like the bud burst. So yeah, just never feel like you don't have options. And just as Emma said, yeah, reach out to SciStarter, because just great information. Always happy to share solutions for your classes.
absolutely, I'll forward them directly to Jill to answer them. Just kidding. I mean, maybe not actually. I'll probably include you in those conversations. Yeah, no, absolutely. If you do need any help with any of these things, or even if it falls through where like you're having trouble making the data, like the data closing the loop concept, reach out, because we might be able to just help you make that happen. Because we've had a lot of individuals who are like thinking they have a whole data set and they have it from their class, and none of them can like submit the data, and it's all in the teacher, and it just sits for a while. But if you let us know that that's what's happening and send us like a spreadsheet of it, for example, sometimes that project actually just benefits from being sent the spreadsheet. So that's not the optimal. You should definitely go for the general data submission process. But if there is ever an occurrence where you're just like this, I'm not sure what to do with it, but it's data, feel free to let us know when we'll help you solve that problem, which is not even a problem. It's a good problem. All right, I just wanted to close this out in the last few minutes, 8 minutes we have left. I wanted to know if we addressed everything that you wanted to know, if there's anything you're bringing back to your students or your teachers that you're aware of, that you know, your friends, and where you might want to see more support from us. So if anything has come up where you're like, oh, this would be helpful, but I want more, or this wasn't addressed and I'm stressed about it, what would that be? You're more than welcome to add that in the chat or the Q&A. You can also send us an email with your thoughts. I'll drop our email in the chat right now, which is info@scistarter.org. Although I'm happy to answer anything right now as well. I'll give it a couple seconds on the screen before I change it. I am going to actually mention a couple of upcoming events because they relate to projects we talked about just now, because we have a few more coming up. SciStarter Live happens pretty much every week with the exception of like our encore episodes where we promote our previous episodes based on the time of the year and whatnot. And so I wanted to share a couple of things with you because on February 6th, so next week is specific to project leader. So in case you're curious about project leadership, feel free to join in. But if you're curious about Frog Watch, which was mentioned, Jill mentioned it, and then I mentioned briefly Monkey Health Explorer. Both of these projects are really great for students, and we would love to have you join to learn more about those specific projects. If you're looking for like those very concrete examples, especially, we demonstrate these projects in real time. So join us again on the 6th or the 13th to talk about those things, and then you can keep an eye on SciStarter Live by going to our blog, which is down here. We'll drop in the chat as well. Oh, it's already there. Thank you, Roland. And you can also register for all of them on that one link, the scistarter.org/go/live is where you would send all of your registrations, where you go. I'm going to check out the chat for a moment to catch up on anything that might have been missed so I can help explain things. But those are our next upcoming events. And there's one more I'll explain in a moment. Melissa, thank you for your commentary. I'm a home educator and am excited to use the tips and tricks you mentioned here to plan something for our homeschool co-op. Yes. Thank you so much. Yay, you are very welcome. I'm very excited for you. Feel free to send us an email or send us pictures of your events. Would love it. We would like to know what people are up to. Last event, I promise. Although not actually. We have so many, just this is like the ones that I've slated to tell you about. We have a partnership with NASA where we talk about these really cool NASA projects that need your help. And so this time around in February on the 21st, at 7 p.m. Eastern time. So most likely when your students are home and they can just be watching online, you can recommend for them to join. It's going to be about winter. So the wintry things that NASA is involved in. So from icy comet trails, did not know comets have ice on them, by the way. So that's news to me as an old person. So from icy comet trails to snow on Earth, which is the more obvious, help NASA unravel the mysteries of frozen landscapes. And it's called What's It Mean to Be Cool? And it's our Do NASA Science Live series. So we're very excited to share that with you all and would love to have you there. If you want to register for that, you can go to our Eventbrite that Roland just dropped in the chat for you. All right, I have talked a lot, so I'm going to pause for a moment. If there are any questions, you're welcome to stay to ask those questions. If not, I'll leave you with this last slide so you can see our information. I did promise also to share with you that link to sign up as a classroom. So if you are a classroom, we would love for you to sign up for 1 Million Acts of Science to make sure that we can get to that 1 million mark, which I will send in the chat run. Oh, Roland's already on it. Just kidding. Go ahead. Go ahead. Join us for 1 Million Acts of Science for your classroom in April, and you can do that from that form that was just put there. And we have a survey. If you want to know more about SciStar Live or tell us what to do next about any of these projects, feel free to let us know, and we will do our best to make it happen. All right, I will pause there and have us close out a good 4 minutes early, unless anyone wants to. Yes, if you or Victor, I see your hand raised in the chat. Did you want to say something? I'll allow you to talk in case you want to add any thoughts. And thanks for joining, by the way. Happy to have you online. I'm gonna stop my screen share. Ta-da! All right. Oh, looks like it might not have been unmuted, or maybe hand up for no reason. All right, well, okay, cool. Yeah, thank you, everyone. And thanks, everyone who was my panelist today. We love your ideas and thoughts, and I'm really glad you all were able to be here. So we'll stay tuned for our next meeting. And yeah, major thank you. I want to send you guys like swag of some sort. Do you already have a Canvas bag? I feel like you do. I feel like you might. We will Climate Summit. Caroline will see you all and it'll be great. Yeah. Thanks, everyone.
Thanks so much. And now everybody wants hot chocolate. I keep
right.
thinking about that NASA cup. Now we want to make hot chocolate.
Fair enough. I agree. We were like in our description, I think it starts with grab a hot cocoa and take a seat for this nice event. I forgot what it says, but it's nice. It's just delightful and delicious. I have hot chocolate actually, so maybe I will go do that right now. Have a wonderful rest of your night, everyone. I'm going to go ahead and close our recording. See you all next time.
Bye, everyone.